Assalamualaikum warahmatullahi wabarakatuh.
And good day to all of you.
In this video, we will talk about angular momentum.
Stay tuned.
Angular momentum. In classical physics, angular momentum is defined where r is the displacement vector from the origin and p is the linear momentum. We can imagine the angular momentum is like a cyclic, which is x, y and z are in cyclically symmetry. From this, we can know that the momentum operator can be obtained by cross product Lx equal to ypz minus zpy, Ly equal to zpx minus xpz, and Lz equal to xpy minus ypx. Angular momentum operator is defined in terms of position and linear momentum operator, and we expect that momentum operator will obey the commutation relation of angular momentum.
The cumulation of angular momentum. First, we have to choose two of the three operators, either Lx, Ly or Lz. So in this case, we choose Lx and Ly. Substitute this, and ypz will interact with zpx, and zpy will interact with xpz. So we get this term. From this term, we use ABC rule, which is ABC is equal to B plus C. AC, AB. And we get this term. We know that PZ is equal to negative IH bar, and ZPZ is equal to IH bar. That's why we get this. You're almost done. We factorize this equation, and we will get IH bar XPY minus YPX. That's it. Wait. XPY minus YPX is equal to LZ. So this is equal to LZ. So IH bar LZ. That's it. Done.
Quantum algebra of angular momentum. It is important for physics and mathematics. The algebra is related to the group of special unitary transformation in 2D and orthogonal group in 3D. This is important in discover the structure that is rather universal.
Now, the question is, what is the value of Lx, Ly, Lz and their position in a certain time? Let's try to find it. What we know now is, we have state, position and momentum operator. But, the problem is they didn't commute. Because of that, we could not tell simultaneously the position and the momentum of the state. So, we can tell that the value of Lx, Ly and Lz at a certain time. In another word, L are undetermined and impossible to know. So, what can we tell? Let's think together. Lx, Ly and Lz is continuously do rotation. So, the only thing that can be possible commute with this thing is rotational invariance. So, what should we do? I need to call Prof. AMIR. Maybe he know what we should do.
So, what should we do? Let's rethink together. We know that L squared is equal to Lx squared plus Ly squared plus Lz squared. In another word, L squared is equal to Lx plus Ly plus Lz. So maybe Lx will commute with L squared. What do you think? Let's try. Lx L squared. We substitute L squared as the Lx squared, Ly squared, and Lz squared. For Lx squared, this should be vanished. In another word, 0, because every operator will commute with itself. This one for Lx Ly squared, and this one for Lx Lz squared. Remember that Lx Ly is equal to I h bar Lz. Same with I h bar Lz. And Lx Lz is equal to I h bar Ly. I h bar Ly. Oops, you forgot it. Negative. Okay. So we write together I h bar Lz Ly plus I h bar Lz Ly minus I h bar Lz Ly minus I h bar Lz Ly. Okay. So this it cancel this one, this cancel this one, and the answer will be 0. That's proof that Lx will commute with L squared. Done.
Surprisingly, Lx and L squared is commute. So now we have a second operator that measurable simultaneously. Because of they are commute, we can get the eigenstate of Lx, Ly, and Lz at the same time.
If we have two Hermitian operators that commute, so we can find simultaneous eigenstate of both operators. From the previous calculation, we get Lx L squared equal to 0, so the Ly and Lz must be the same, which is both equal to 0.
So what we have to do now is choose two operators, either Lx, Ly, or Lz, because we're gonna use that to form simultaneously eigenstate. The idea is we choose two operators and then try to find the function that are eigenstate of both operators. By the function, we will try to expand in the term of this function, and we hope that all of the operator will become a number acting on those functions. Why we have to know about simultaneous eigenstate? Imagine that we have one box. In that box, there are 1,000 atoms that keep moving. So, how to differentiate between those atoms? The only way that we can differentiate them by using properties, because different atoms have a different properties. Some of the properties is energy and momentum. By know the eigenstates, so we can know the momentum of the atom.